Assalamualaikum warahmatullahi wabarakatuh. Welcome to our presentation video. Now we are going to present our presentation that entitled Binary Search in Python. So let me introduce our team. First, my team Yudhistira, my team Virgi, and me Siti Rayhannah. And I will explain about binary search in Python. Binary search is a data search technique by repeatedly dividing half of the amount of data search so that it reduces the search location to one data. With this technique, we will remove half of the amount of data. If a match is found, the program will return the output. Otherwise, the search will continue until the end of dividing the amount of data. And Python is a programming language that can execute a number of multi-purpose instructions directly with object-oriented programming methods and use dynamic semantics to provide a level of syntax readability. So, a binary search is an algorithm to find a particular element in the list. Suppose we have a list of 1,000 elements, and we need to get an index position of a particular element. We can find the element's index position very fast using the binary search algorithm. There are many search algorithms, but the binary search is most popular among them. The elements in the list must be sorted to apply binary search algorithm. If the elements are not sorted, then sort them first. So here we have a sorted list of the elements, and we are looking for the index position of 45. So we are setting two pointers in our list. One pointer is used to denote the smaller value called low, and the second pointer is used to denote the highest value called high. Next, we calculate the value of the middle elements in the array. As formula shown on the screen, now we will compare the searched elements to the mid index value. In this case, the 32 is not equal to 45, so we need to do further comparison to find the element. If the number we searching equal to mid, then return mid, otherwise move to the further comparison. The number to be searched is greater than middle number. We compare Bn with the middle element of the elements on the right side of mid and set low to low, mid plus 1. Otherwise, compare the Bn with the middle elements of the elements on the left side of mid and set high, mid, min 1. Repeat until the number that we are searching for is found. And in the binary search algorithm, we can find the element position using the following methods: recursive method and iterative method. So next explainer is Yudhistira.
Okay, thank you. So now we have the implement iterative binary search in Python. First, we have to create a function called the binary search function, which takes two arguments, a list to sort and a number to be searched. We have declared two variables to store the lowest and highest values in the list. The low is assigned initial value to 0, high to len, list 1, min 1, and mid as 0. Next, we have to declare the while loop with the condition that the lowest is equal and smaller than the highest. The while loop will iterate if the number has not been found yet. In the while loop, we find the mid value and compare the index value to the number we are searching for. If the value of the mid index is smaller than n, we increase the mid value by 1 and assign it to the search move to the left side. Otherwise, decrease the mid value and assign it to the search move to the right side. Next. Next. If the n is equal to the mid value, then return mid. This will happen until the row is equal and smaller than the height. If we reach the end of the function, then the element is not present in the list. We return min1 to the calling function, and the output is element is present at index 4. Next. Implement a recursive binary search in Python. The recursive method can be used in a binary search. In this, we will define a recursive function that keeps calling itself until it meets the condition. The above program is similar to the previous program. We declare a recursive function and its base condition. The condition is the lowest value is smaller equal to the highest value. We calculate the middle number as in the last program. We have used the if statement. Proceed with the binary search. If the middle value equal to the number that we are looking for, the middle value is returned. If the middle value is less than the value we are looking, then our recursive function binary search again and increase the mid value by 1 and assign to low. If the middle value is greater than the value we are looking, then our recursive function binary search again and decrease the mid value by 1 and assign it to low. In the last part, we have the Raden augment program. It is the same as the previous program, but the only difference is that we have passed two parameters in the binary search function. Next. And this is because we can assign the initial values to the low, height, and mid in the recursive function. Every time the recursive is called, the value will be reset or those variables. That will give the wrong result. So we have the output of the program is element is present at index 2. In the next slide, we will explain by my friend Virgi. Thank you.
Okay, thank you, my friend Yudhistira Nuzuli. I will explain about the implementation Python in the complexity of the binary search. The complexity of the binary search algorithm is 0, 1 for the best case. That simple for remember the best case in binary search. And this happen if the element we are looking find in the first comparison. For the worst case and the average case in the binary search is 0 log n. This depends upon the number of search are conducted to find the element that we are looking for. Next. Okay. And now I will explaining about best case and the worst case condition previously on the previous slide. And for the best case condition is used in computer science to describe an algorithm behavior under optimal condition. Example, sort the array of items which are already sorted. Binary search is when the element you are looking for is right there in the middle of array. The best case conclusion can be drawn as follows: Tn equals T1. And we can find the big zero notation for the best case is 0, 1. And the best case can find in the iterative method. In this method, The iterations are controlled to looping condition. The space complexity of binary search in the iterative method is 0, 1. For the worst case condition, is used to analyze the algorithm behavior under worst case input and least possible to solve the problem. It determines when the algorithm will perform worst for given inputs. And almost worst case condition find in recursive method, which has been explained by my friend Yudhistira. Next. And this is our conclusion and suggestion. For the conclusion, the binary search algorithm has better complexity than other search algorithm, so that binary search perform is better than others. In binary search, it will only look for the one side only if the middle value has been found. There are conditions which are this algorithm has disadvantage and disadvantage. For disadvantage, if the data you are looking for is at the beginning of the element. In general, other algorithm will find the result you are looking for the first compared to binary search, or the situation are the worst case in binary search. And for advantage for binary search, if the search data is exactly at the time the element is divided by 2 in binary search, then binary search will find it compared to other search algorithm, or it called the best case condition in binary search. Next. And for suggestion, if you using binary search, is to be careful for the calculation process, because the data can be not found in binary search, or even if data is not found, so use another search program. And if the data usage has not been sorted, but it will be different if you run the sorting program first. However, it will make the processing time longer. Okay, next.
Okay, that's all our presentation. Thanks for watching our video. And the last I say, wassalamualaikum warahmatullahi wabarakatuh.